Okay, these are, I think, some questions from the first review. There are 3 reviews corresponding to the 3 short parts of the test. First one is the one that has to do with, it's not very hard. It's really not very hard. I'd say it's relatively easy. The middle one is a little harder, and the last one is very simple. The last one's the graphic one. Let's run through these though. I have constructed the reviews to be similar to the tests, and they're going to be a little easier because I want you to be able to finish them, quickly. So you have to be able to do the same processes, but I've toned them down just a bit. Okay, so what about these properties of exponents? Let's start off reviewing that a little bit. Okay, what's this one? And why? It's 1. How come?
Because anything to the 0 power is 1.
Anything to the 0 power always equals 1. Okay, the 0 exponent property. So we know that this one is 1, end of story. Okay? What about that? What are we going to do there? Okay, yeah, I'm going to have to, whenever I have a bunch of stuff that's multiplied and or divided, all taken to a power, I have to distribute that exponent, don't I? Which we can do. It might be useful, though, to do something else first. If we follow order of operations, before we do exponents, what should we do? Parentheses, yeah, so let's simplify inside the parentheses first, how about? Either one would work, though, honestly. Okay, but if we simplify in the parentheses first, tell me what goes where. What goes on the top? Okay, so we got a 9. Because the 9/7 does not reduce, does it? Now, we would want to reduce the fraction if we could, but we can't. The 9 stays on the top, 7 stays on the bottom. What about the V? What do we do with the V? Okay, I heard 2 correct things there. Keep it on the top because the exponent is bigger on the top, and we'll subtract the bottom exponent, right? So we end up with V to what power? Squared. So what about the X's? Okay, on top, squared. Same thing, right? 5 minus 3 gives us 2. Now, what about that 3 outside? What do I do with that?
Distribute.
Okay, I can distribute, because these things are not being added or subtracted, they're being multiplied and divided. I can distribute it to all 3 parts, right? So what's that going to give me on top then? 9 cubed, big number, 729, times what's V squared cubed? Is it V to the 5th or V to the 6th? 6. If we take a power to a power, we multiply. If we multiply like bases, we add, right? But this is different. We're taking the power V squared to the power 3. Power to a power, we multiply. So V to the 6th, x to the 6th over 7 cubed, which is 343. So that's our final answer. Okay, can we go any further? That's it, isn't it? Now, how do we know we can't reduce 729 over 343? Simple. Because you can't reduce 9 over 7. 729 is built only from 9s. 9 times 9 times 9, right? 343 is built only from 7s. 7 cubed. So if 9 over 7 doesn't reduce, 9 cubed over 7 cubed can't reduce either. Right? Okay? Questions? All right. What about this? It looks terrible, but it's really simple. What do you do with a problem like this? Add like terms, yeah. When you're adding polynomials, all you're doing is adding like terms. And when you're subtracting polynomials, it's almost the same thing. What's the only little bit of difference we have to do here? Notice this one has a positive 1 out in front, so we don't even need those the parentheses, do we? This one is being added, so we don't even need the parentheses. We can just add like terms, but this guy in the middle is being subtracted. So what do we have to do because this one is being subtracted?
Distribute -1.
Yeah, well, I think the easiest thing to do here is just to distribute the -1 all the way through and then add that polynomial. So if I were to distribute the -1 all the way through, isn't it just going to give us for this polynomial, are we just going to get positive 5x to the 4th, positive positive 8x cubed, positive 5x squared, minus 3x, minus 2. And I'll just add like terms, be done. Okay. Make sense? Okay. Questions? What about that? What are my options on this one? If I want to expand out 2x minus 5 cubed. I can. How could I rewrite that if I really wanted to? Say it again. I could write it as a product of 3 factors. Good, I could. I don't think this is the best way, but it works. I could write it as 2x minus 5 times 2x minus 5 times 2x minus 5. And how would I multiply those out? Yeah, I'd have to do 2 at a time, right? I'd have to take, for example, like these two and FOIL those out and get a bigger simplified polynomial and then multiply that one exactly and have to distribute the 2x minus 5 through again. That's one way to do it. It seems like people tend to like that way the best. Here's the way I think is the best, but really it's up to you how you want to do it. I think the best way to do it is to use the patterns. So if we have 2 patterns that you really should know. A plus B squared equals, do you remember what the expansion is for that? A squared plus
AB
2AB plus B squared. Now, how can you remember that? How could you recreate that if you didn't remember it? There actually is a way you can. Okay, you know that for one thing, it's always going to have one more terms than the power. So if it's A plus B squared, you know you're going to get 2 plus 1 or 3 terms. Here's the pattern. Here's how you can recreate this. You know that the exponents always add to 2. So 2, a to the 1 adds to 2, and then b squared, right? Always add to 2. You're always starting with all the exponents shifted towards the first variable, and then it just does that, right? The a goes down, the b goes up by 1 each time. And what about the coefficients? The coefficients of the first and the last are always, no matter what the power is that you're expanding, it's always 1. And here's the other trick. This one really helps. Whatever the power is, if it's a plus b squared, that's always going to be the second coefficient. Okay? Every time. So there's a plus b quantity squared. Now what about a plus b quantity cubed? Because that's really, that's really what we need here, isn't it? So what's the first one going to be then? Got a 1 is the first coefficient. It's got to be, add up to 3. It starts with all A. Now what? What number? 3, right? Whatever the power is, that's your first coefficient. So it's plus 3. Then the A goes down by 1, the B goes up by 1, right? Plus, now notice that this is going to have 4 terms, right? The coefficients have to mirror each other. It has to be, if it goes 1, 3, then it has to go 3, 1. Okay, it has to be the same pattern. So it's going to be 3, A goes down to 1, B goes up to 2, plus 1. Right, there's my 1. A goes down to 0, B goes up to 3, just like that, right? How does that help us? Well, we could just plug in the values of A and B into that expansion pattern and get the answer, I think, more quickly. If you just know the expansion pattern, it's quicker to get to this big answer this way than by having to go through this multiplication process twice. Let's quick look at how we do that. Okay, so for this pattern, in this example right here, what's A equal to? Everybody agrees 2x. What's B? -5. We're adding -5, aren't we? So then those are the numbers that those are the expressions that we're going to be substituting up here into this pattern. So A cubed is just going to become 2x cubed. a squared becomes 2x squared, b becomes negative 5, right? Plus 2x to the 1, negative 5 squared, right? Plus the last term would be negative 5 cubed. And all we have to do then is just simplify that. Right, so what do we get? 2x cubed, I have to distribute the 3, don't I? I have to cube both the 2 and the x. So that just becomes 8x cubed, right? What about this? I'm going to get 3 times 2 squared is 4, right? So I'm going to get 4x squared times 3 times negative 5. 12 times negative 5 would be negative 60 x squared, right? What about the third term? So I'm going to get 3 times 2x times negative 5 squared. What's negative 5 squared? 25. So that becomes 25. 3 times 2 is 6 times 25 is 30. I mean 150, sorry. 30, 150 times x. Now I'm kind of going through the arithmetic fast, but I just want to get through lots of examples. And then negative 5 cubed is just negative 125. Okay? I mean, you can take your pick, honestly, whichever way you prefer. I definitely prefer that way, but I don't know, maybe you like the other one better. That's fine. Okay, dividing polynomials. I want to look at a quick example using, you know what, actually, let's do a little different one. I'm going to trade that one for that guy right there. Okay. Oh, same one.
I was wondering if you noticed that.
No, I didn't, obviously. Okay, let's try that one. How about it? Okay, so if I divide, now this is a case where I can use synthetic division because the bottom is simple. As long as the denominator looks like x plus a number or x minus a number, I can use synthetic division. All right, so how do I do that? I make my bracket, but what goes where? Okay, yeah, on the outside, what is it that goes on the outside? 1 or negative 1?
Negative 1.
Negative 1. How do you remember that?
Because x minus k.
Okay, because it's in the form x minus the number that goes outside, x minus k. X plus 1 is really x minus negative 1, isn't it? The other way to think about it is you're finding the 0 of the denominator, which means all you really have to do to find out what the number is set the bottom equal to 0 and solve. Either way, doesn't matter. Either way, we're getting the number negative 1 out front. Okay? So negative 1 goes out front. What goes the other places?
Coefficients.
Okay, coefficients. Now what happens, I've got all my coefficients here, but what if I was, for example, if I didn't have an x term? Got to put a 0, right? You got to make sure you have numbers for every coefficient. Even if one's missing, you need a 0. So 3, 1, negative 4, negative 4. What's the last thing I could draw here before I even start?
Box.
Yeah, good, the remainder box. And so now we do our synthetic division. What's that look like?
Right down the 3.
Okay, times by negative 1. Add or subtract? Add, good. Negative 2, so I get positive 2. negative 4 and 2 is negative
Two.
2 times negative 1.
2.
And if I add, what do I get?
Negative
Negative 2. Okay, so there's my answer, but I gotta write the answer out now. So how do I interpret that?
2. AX squared plus BX plus C.
Okay, so these are the coefficients of the polynomial part of the answer, right? That's gotta be the constant, coefficient of x squared, x cubed if it were there, etc. So that's gonna look like 3x squared minus 2x minus 2 plus what?
2.
Okay, good. There's my remainder is negative 2. And what goes on the bottom?
X plus 1.
Yeah, because the remainder is what remains over the denominator. Good. All right, you guys are getting this stuff. This is good. Okay, long division. You get one of those. There's a lot of room to make mistakes on these, but I didn't give you, on the review, nor will I on the test, I didn't give you real big ones to do here. So there's less of a chance of making a mistake. You still have to know how to do it, but I tried to kind of tone them down a little bit. So what goes where? Okay, the denominator's on the outside. And the numerator's on the inside then, right?
Yep.
Once again, if there's a missing term, and there's not, I have to include a 0 coefficient. I have to have columns for each power of x here, don't I? So 8x cubed minus 6x squared minus 18x minus 1. Good. How do I know what the first term of my answer is? What do I do?
Find when 2x squared is 8x cubed.
Okay, I want to know how many times does the leading term outside divide into the leading term inside? In other words, 8x cubed divided by 2x squared is what?
4x.
Okay, and you guys are all getting really good at that, it seems like. So, 4x. Now what?
Distribute 4x cubed with the divisor.
Okay, I'm going to distribute. The 4x goes all the way through the outside terms, or through the numerator or denominator, right? Okay, and if we do that, we get
8x cubed.
4x times negative 2x.
Negative 8x squared.
Okay, and you want to make sure you're lining up the powers of x, okay? So 4x times negative 5. And this might not seem like a big deal, but it is. Put parentheses around the whole thing and subtract. Now notice that because you've lined up the powers of x, you can just focus on the coefficients when you do your subtracting. So in the x column, 8 minus 8 cancels. In the x cubed column, sorry. In the x squared column, negative 6 minus negative 8 gives you 2. And those are x squareds, good. In the x column, negative 18 minus negative 20,
2x.
2x. And what do I do with the negative 1?
Drop it down.
Drop it down. And start again. So, leading term outside, my new leading term inside. Outside leading term 2x squared times what is 2x squared? 1. Okay, so we distribute. That's easy. Just multiplying 1 just means I'm copying, right? So that just goes down here. Subtract. The 2x squareds cancel. In the x column, I get 2 minus negative 2. What's that? 4. Good, and I have x's, so 4x. Negative 1 minus negative 5?
Plus 4.
Plus 4. Okay, so that's my remainder,
Plus
isn't it? Plus 4, thanks. So,
Done it.
there we go. How's that? Okay, so that's the remainder because now the power of x here is smaller than the power of x outside. 2x squared won't divide into 4x anymore, will it? So that's my remainder, and what's my answer look like?
4x plus 1.
So here's my polynomial part. 4x plus 1 plus
4x plus 4.
over my denominator. the end of the first review. That's it. We just did it, whole thing. Completely factored. Okay, I toned these down a little bit too. Now let's go through some factoring stuff. This is probably the harder of the tests, but you're gonna be surprised. This is not that big a deal. When I factor 4 terms, what's my strategy for 4 terms? By grouping. And it's easy to remember because there's an even number of terms, so I can split the groups up evenly then, right? So we end up with first 2 terms, x cubed minus 10x squared plus. Don't forget the plus sign. People have a tendency to forget that, and they write the other group right next to it, and it looks like they're being multiplied, and they get messed up because of that. So plus the second group is negative 25x plus 250. And what do? Now that I've got this grouped, what do I do with the first group? Greatest common factor. What's the biggest thing I can take out of the first group? X squared. Everybody see that? I can't take any numbers out, but I could factor out or undistribute an x squared, right? Factoring something out means undistributing or really just dividing. All I'm doing is I'm dividing each term by x squared, dividing it out to the front. What's left behind if I divide those terms by x squared?
X minus 10.
Yeah, everybody see that? X minus 10. And we know what the pattern is here, right? If this is going to work, I have to get this consistent pattern. Now, which part has to be the same if it's going to work? The x minus 10. And for that to work, what would the number in front be? Yeah, and we just ask ourselves, what times x is negative 25x? Negative 25, and see if it works on the other one. Negative 25 times negative 10 is positive 250. So it works there too. So the pattern worked. Now, how does it factor? Now that we know that the pattern is working, how do I write it as a product of factors?
X squared minus 25 times x minus 10.
Yeah, I've got my common factor that I can factor out, leaving me with an x squared minus 25. Okay, but the instructions say to completely factor. So we factored it, but can we go further?
Yes.
Yeah, now that one's done, isn't it? But what about this guy here, x squared minus 25? Is there a pattern that fits? The difference of squares. Real quick, let's just review our patterns. So we know that we've got a difference of squares pattern. A squared minus b squared factors into what? What's the difference of squares? A squared minus b squared is, say it again, a plus b, a minus b,
Yeah.
right? Or either order, doesn't matter. Okay, that's one you gotta know. Then the other two are the cubes. A cubed plus b cubed and a cubed minus b cubed. Remember, those have a small factor and a big factor, right? So what's a cubed plus b cubed? Sum of cubes. How does that one factor? A plus b, and then we're going to get an a squared, right? Minus. We always start with the same sign that we're factoring. Alternate, so it becomes minus, and ends up with a plus every time, right? Okay, so what's a cubed minus b cubed? A minus b, a squared plus ab plus b squared. Okay. What about sum of squares? Doesn't work. Does not factor, right? Doesn't factor. Can't do anything with it. Okay. So this one then is which pattern?
Difference of squares.
Difference of squares, because 25 is 5 squared. So we could just write this as x minus 10 times x plus 5 times x minus 5, right? And that's it, as far as we can go. Now, what if we got an answer that looked like this? What if we got an answer that looked like x plus 2 times x plus 2 times x minus 1? Would I write it that way? What would I do? You're right, that's not simplified.
X plus 2 squared.
Good, I could write that as x plus 2 squared times x minus 1, right? Okay, good. Okay, what about that one? These people, I think once you get over the hump on these are the easiest ones, but you gotta kind of see it first of all, right? When we have three terms like this, if we can write it in a quadratic form, then we can use all of our chapter 5 bag of tricks on it, right? What does quadratic mean? Well, quadratic just means A, remember what that means? It's just A times something squared plus B times the same something plus C, right? In chapter 5, those somethings were always x's, right? But in chapter 6, we look at cases where there's something else, like maybe x squared, right? Still quadratic though. Coefficients are still A, B, and C. That's what we have here, isn't it? We have something squared plus 5 times something plus 4, and the something is just an x squared, right? So everything we did back in chapter 5 works now, only it's working for x squareds instead of x's. So back in chapter 5, the easiest kind of factoring we did was stuff like this. If we had x squared plus 7x plus 12, how did we factor that? What was our thinking on this? This was the easy kind though, right? A equaled 1, so we didn't have to do that dreadful A times C then split B, right? This just unfoils. When it unfoils, it means that first times first has to equal x squared, and last times last has to equal 12. So the first two terms have to be x's, don't they? Because they have to multiply to, right? They have to FOIL to x squared. Okay, what do the other two numbers have to do? Multiply to what and add to what?
Add to 7.
Good, they have to multiply to 12, don't they? Because last times last is 12, and they add to 7. So what would my numbers be here? 4 and 3. Okay, well what about our example's a little different. What about ours? We can do the same pattern though, can't we? We can still unfoil this because it's quadratic. And notice that A is still equal to 1. That's good, right? That makes things easier. So then we just end up with first times first has to be x squared squared. So what are my first terms? X squared. X squared times x squared is x squared squared. The other two numbers have to, what? Multiply to what and add to what? Okay, they got to multiply to the last, to 4, add to 5, so what are those? Okay, can I go further? Can't, can I? Because that's sum of squares pattern. Difference of squares, yes. Sum of squares, no. Right? Doesn't work. Okay? What about these? Now, we made these pretty easy. In the book, they talk about always solving these by factoring. And you can, it's fine. We could factor this as a difference of cubes, but we don't have to, do we? We have a shortcut. The chapter 7 shortcut I gave you early. What do we do to solve for x there? Isolate. Sure, we're just going to isolate the same way we did in chapter 5. There's just a couple rules to remember, but they're easy rules. So if I want to isolate x, what's the first thing I do? Add 125. So 216 x cubed equals 125. Now what? Divide by 216. So x cubed equals 125 over 216. Now what? Not square root. Cube root. Okay, now whenever we square root, we always have to include a plus or minus. Do we with the cube root? No, we don't. How come? It's odd. Whenever we take an odd root, so a third root or a fifth root or a seventh root, no plus or minus. Only with even roots, square roots, fourth roots, sixth roots, etc. So then our answer is just x equals the cube root of 125 over 216. And just like with square roots, we can break that up into a separate top and bottom. And what's the cube root of 125? 5, yeah. Cube root of 216?
No,
the answer's 5, 6. Okay? Questions? It's not so bad, is it? This is a lot easier in chapter 5, don't you think? You kind of look at it all together. Okay, what about that? Very simple. Looks hard, but very simple. 3 terms, that's one of those quadratic ones, isn't it? Right? So this is quadratic if we break it up into x squares. Something squared plus 20 something plus 91 equals 0. Well, if I want to solve a quadratic equation in standard form, what's always my option? Quadratic formula, sure. I can always solve a quadratic equation in standard form with the quadratic formula. Quadratic formula just tells me that whatever the something is, used to be x's, whatever the something is, if a is 1 and b is 20 and c is 91, it's equal to negative b plus or minus square root b squared minus 4 times a times c divided by 2a. Now what's the something this time?
X squared.
X squared. Right? So all we have to do is simplify that, and those are my solutions for x squared. Okay? So what do we get? Well, we get x squared equals negative 20 plus or minus, so we're going to get, I'm supposed to be quick about this, that's going to be 400 minus 364 is 36. So that's going to be square root of 36, which is what? 6. Okay? Divided by 2. And that gives us negative 20 plus or minus 6. So I get 2 answers, don't I? I get the answers either x squared equals negative 20 plus 6, which is what? Negative 14 over 2.
Negative 7.
Negative 7, or x squared equals negative 20 minus 6, which is negative 26, over 2, negative 13. Do I get any real solutions? When I square, exactly, I still have to solve for x, right? These are just the answers for x squared. I'm supposed to solve for x. So what do I have to do to this equation to solve for x?
Square root.
Square root. But here I'm getting square roots of negatives, right? So are there any real solutions? None. I think the instructions just say enter in if there are no solutions. Now what if, hypothetically though, what if this had been like a positive 13? Just pretend. X squared equaled 13. What would my 2 solutions have been for that? If x squared were to equal 13, then x would equal what? How do I solve for x? Square, you told me square root, but I got to put a plus or minus there, right? So I'd have to enter one for both the square root of 13 and negative square root of 13, right? Okay? That's the only extra step, though, right? Same step we did in chapter 5. The only extra step is just square rooting both sides to solve for x. Okay? All right, keep going here. We're making good time. This is great. Okay. Okay, yeah, what about one of these? Okay, I would argue this is maybe a little easier problem. Sure, it's factoring, but factoring is pretty simple because you're given a factor, right? Completely factor the polynomial and write it in factored form is what it says, given one of the zeros or one of the factors, can't remember what the wording is. So we know that x cubed plus 9x squared plus 9x plus 81 is what we're going to factor. We always want to start off by factoring out a greatest common factor. Is there one? Not this time, is there? Right? There's nothing I can take out of all those terms. But we know that's gonna factor into what? Okay, well, remember what this is really the key here. This is the part you gotta know to do this problem. If f of -9 is 0, what's that saying? If -9 is a 0, that's an x value that makes the function equal 0, then what's the factor that goes with it? X plus 9. X minus -9, which is the same as x plus 9, right? So that's one of my factors is x plus 9. I just have to find the other one, right? How do I find the other one? Divide, sure, I'll just use synthetic division. I would know that the other one is going to be what I get when I divide the polynomial by x plus 9, right? So all we have to do is this. 1, 9, 9, 81. What's the number that goes out front? -9. What goes in there? 0. Because we know it's a factor. That's a 0, right? And then we just need to find what these coefficients are. So I bring the 1 down. Somebody's messing with me here. There we go. Okay, so bring the 1 down. -9 times 1 is -9. Those add to 0. 0 times -9. 0 plus 9 is 9. -9 times 9. -81, so it works. So what does this mean, though? Those are the coefficients of the other factor, aren't they? So that's constant coefficient of x squared. So I just get x squared plus 9, right? Now we have to ask ourselves, can we go any further? Can we?
Yeah.
What's the pattern that's going to work then? Is there a sum of squares pattern for us to use? That's the one that doesn't exist, so we can't go any further. If that were x squared minus 9, we could. But that's as far as we can go, that's our answer. Okay, make sense? Okay, the other one like that, that's a little bit easier, I think, is where you have to find the rest of the zeros. Okay, but these are easier because you don't have to factor it. You only have to factor it if you want to, but you don't necessarily have to. So find the other zeros, use the given 0 to find the other zeros, real zeros, right? Not imaginary ones. We're not getting any imaginary stuff in chapter 6. We're only focusing on real numbers. Okay, so if 5 is one of the zeros, right, I have to find the other zeros. What's my technique for doing that? In that last example, remember, we found the other factor. We know that this is breaking up into we're trying to find the zeros of this, right? Now we could factor out a greatest common factor, if we can. Is there one? Is there a number that goes into all those? 3 does. Yeah, if I add up the digits, they all add up to something divisible by 3. So I could factor a 3 out, and that leaves me with x cubed minus 8x squared plus what? 18x minus 15. I could just divide both sides through by 3, couldn't I? Get rid of that. So there, I trimmed it down a little bit. I just essentially divided both sides by 3. Okay, now I know that 5 is a 0, so I know this thing is going to split up into x minus 5 times something, right? The something is what I get by dividing. Okay? So we'll just synthetically divide again. And that's, you have to agree that synthetic division is not very hard to do. So there's our bracket. The coefficients are gonna be 1, -8, 18, -15. The 0 is 5, right? And we know a 0 goes there, so what do we end up with? Bring the 1 down, times 5, plus -8 is -3, times 5 is -15, +3, 15, and it works, right? So these are the coefficients of my other factor. Right? So that's what we've accomplished. We've gotten this thing broken up into the factor x minus 5 times the factor x squared minus 3x plus 3, right? I just need to find the zeros of that one. The zeros of the function are the zeros of the factors. So we already have x equals 5. That was given to us. To find these, aren't we just doing setting the factor x squared minus 3x plus 3 equal to 0 and solving? How do we solve a quadratic equation in standard form? Quadratic formula. Unless it factors easily, but this one doesn't, right? In fact, maybe this one doesn't even factor. We'll see. Maybe it doesn't even work. Did we even need to do that though? Not really. Because when we did the when we did the synthetic division, we got our coefficients here. Aren't they just a, b, and c? We could have just jumped right into the quadratic formula right there, couldn't we? Right? Either way, we know we're going to get x equals -b. Well, that's a, b, and c, right? So 3 plus or minus the square root of b squared would be 9, minus 4 times 1 times 3 all over 2. Well, what's happening inside the radical there? What's 9 minus 4 times 1 times 3? It's negative, who cares? It's negative. So what am I going to get for my answer then? If I take the square root of a negative? I'm getting i's, yeah. So I can just stop. I'm getting no real zeros out of that, okay, because I'm going to get i's in there. So my only answer is 5. It's only 1. Okay. Last one. Wow, this is pretty good. My goodness. Okay. Oops. What do I want to do? There we go. Okay. So we have to find the missing dimension. Well, what do we know here? Right? We know that, isn't it the product of the dimensions equals the volume?
Yes.
Right? So we know then that, in other words, x plus 10 times x plus 8 times, let's just call this d, equals that. So how am I going to get d by itself? I'm just trying to solve for d. What could I do? Okay, yeah, I could multiply out x plus 10 times x plus 8 and then just divide everything on the right by that polynomial, but I'd have to use long division, right? Look at these factors. These factors are easy ones. They're x plus a number or x minus a number, so I could just divide synthetically, couldn't I? Right? So I could take my my original polynomial, which has coefficients 1, 24, 188, 480, and we could, what's the number I'd put out front if I divide by x plus 10? Negative 10. Okay, and what goes here? 0. Okay. So if I do this, bring down the 1 times negative 10, negative 10, 14, negative 140, 48, and negative 480. Worked, right? Okay, so when I divide away the x plus 10, I'm left with that polynomial. Now what?
Do it again.
Do it again. Now I want to divide what I was left with by the x plus 8, right? To get the d by itself. That's all I'm really doing is getting the d by itself. So I'll just do my little nested synthetic division trick, right? See where we're going with this? All right. Very good. Test tomorrow.